Hi parents, thank you for clicking into this video. Just a brief introduction, I'm Elaine and I am Jimmy's colleague from Great Solution Jimmy Math. In this series of tutorials, I would be explaining common PSLE questions that involve ratio. These questions would have a difficulty level ranging from 1 to 3, with 1 being the easiest. So, what are level 1 ratio questions like? They typically involve what we call constant side or constant total ratios. Constant side ratio means that one side of the ratio should have the same number of units, while constant total means that in the total column of the ratios, they should have the same number of units as well. Let's take a look at a constant total question. Now this question is taken from MGS prelim paper from last year and it is worth 2 marks. The pupils in a school are divided equally into group X and group Y. The ratio of the number of boys to the number of girls is 3 to 1 in group X and 1 to 2 in group Y. What is the ratio of the total number of girls to the total number of pupils? Now the key concept of this question is constant total. Since there is an equal number of pupils in group X and group Y, the total units for group X and the total units for group Y should be the same. To start, we simply write down the ratio as stated in the question. For group X, the boys to girls is 3 to 1, and for group Y, the boys to girls is 1 to 2. Since we are comparing the total units, we should add a column for the total. And for group X, it will be 3 plus 1 equals 4, and group Y, 1 plus 2 equals 3. Now at this point, some students might be a bit confused because we know that there should be the same number of pupils on both sides, but this is not being reflected in the ratios. So at this point, what should we do? We should try to manipulate the ratios such that the total units on both sides are the same, therefore constant total. So the lowest common multiple of 4 and 3 is 12. So what we do is we simply multiply this ratio by 3 and this ratio by 4. Now when we multiply, make sure that we multiply throughout. Okay, so 3 times 3 is 9, 1 times 3 is 3, 4 times 3 is 12. And we multiply by 4 throughout on this side, which would give us 4 to 8 to 12. So now we have successfully made the total units the same. And this makes sense now to the student. Okay, so let's read the question again. We want to have the ratio of the total number of girls to the total number of pupils. So the total number of girls is reflected here and here. And the total number of units is already highlighted. So let's do a quick calculation. The girls to the total students would be 3 plus 8 over here and 12 plus 12 over here. That would give us 11 to 24. Now, since 11 and 24 cannot be reduced to a simpler form, this would be our final answer. Now, let's move on to another question. This question involves constant side ratio, and it is actually taken from the same paper, worth 2 marks. The ratio of the number of 10-cent coins to the number of 20-cent coins in a purse was 3 to 5. When 60 20-cent coins were removed, there was an equal number of 10-cent coins and 20-cent coins. How many 10-cent coins were there in the purse at first? Now we should also highlight equal number because that is very crucial. Now, the key concept of this question is constant side. Since the number of 10-cent coins remain unchanged, the total number of units for 10-cent coins in the before and after ratio should be the same. How do we know that the number of 10-cent coins remain unchanged? It is stated here that only 60 20-cent coins were removed. So basically nothing happened to the number of 10-cent coins. Since this is a before and after question, we should make use of the Bca model. Okay, if you haven't watched our previous videos, Bca means before, change, and after. Okay, we are comparing 10-cent coins to 20-cent coins, so let's write that down. In the before situation, the ratio was 3 to 5. And the change basically means what happened. So 60 20-cent coins were removed, so we would write a minus 60 over here. And in the after situation, there was an equal number of 10-cent and 20-cent coins. So when there's an equal number of units, in the simplest form, it would be 1 to 1. So what's problematic now is that the units representing the 10-cent coins are different. Okay, they should be the same since the number of 10-cent coins did not change. So what we should do is to manipulate the ratio again to make this side the same. Therefore, constant side. So 1 can easily become 3 simply by multiplying by 3. So the new ratio for the after situation would be 3 to 3. Now that we have made the units the same for the 10-cent coins, it now makes sense. So going back to the question, how many 10-cent coins were there in the purse at first? Okay, we compare the number of units in the before and after situation for the 20-cent coins. Since there is a drop of 2 units, 2 units would be equal to 60. Therefore, 1 unit would be 30, and the number of 10-cent coins, 3 units, would be 30 times 3, 90. And that would be our answer for this question. In the next video, I would be explaining some level 2 ratio questions. If you have any questions for me or have any suggestions as to what kind of topics you'd like to see me explain in upcoming videos, please leave a comment in the comment box below. And also subscribe to this channel for more free tutorials.